What is Euclidean geometry?
Euclidean geometry is named after Euclid, the famous Greek mathematician. It is geometry mostly based on Euclid's fifth postulate, the parallel postulate, and is sometimes called parabolic geometry. Plane geometry is described as two-dimensional Euclidean geometry, while three-dimensional Euclidean geometry is known as solid geometry.
Who were the Akkadians?
The region of Mesopotamia was once the center of the Sumerian civilization, a culture that flourished before 3500 BCE. Not only did the Sumerians have a counting and writing system, but they were also a progressive culture, supporting irrigation systems, a legal system, and even a crude postal service. By about 2300 BCE, the Akkadians invaded the area, emerging as the dominant culture. As most conquerors do, they imposed their own language on the area and even used the Sumerians' cuneiform system to spread their language and traditions, although the Akkadians brought a more backward culture into the mix. They were responsible for inventing the abacus, an ancient counting tool. By 2150 BCE, the Sumerians had had enough. They revolted against the Akkadian rule, eventually taking over again. However, the Sumerians did not maintain their independence for long. By 2000 BCE their empire had collapsed, undermined by attacks from the west by Amorites and from the east by Elamites. As the Sumerians disappeared, they were replaced by the Assyro-Babylonians, who eventually established their capital at Babylon.
What is the law of total probability?
The law of total probability can be written as follows: the probability that an event A will occur, P, A, is equal to the probability that event A and event B both occur, plus the probability that event A and event B occur, or A occurs and B does not. Using the multiplication rule, this is written as P, A, equals P, AB, P, B, plus P, AB, P, B.
What was the first civilization to use a decimal system of weights and measures?
Between 2500 and 1700 BCE, the Harappa, or Harappan civilization of the Punjab, now a province in Pakistan, developed the earliest known decimal system of weights and measures. For more about decimals, see Math Basics. The proof was first found in the modern Punjab region, where cubical, some say hexahedral, weights in graduated sizes were uncovered at Harappa excavations. Archaeologists believe that these weights were used as a standard Harappan weight system. represented by the ratio 1:2:4:8:1632:64. The small weights have been found in many of the regional settlements and were probably used for trade and or collecting taxes. The smallest weight is 0.8375 grams, 0.00185 pounds, or as measured by the Harappa, 0.8525, the most common weight is approximately 13.4 grams, 0.02954 pounds, or in Harappa, 13.64, the 16th ratio. Some larger weights represent a decimal increase, or 100 times the most common weight, the 16th ratio. Other weights correspond to ratios of 0.05, 0.1, 0.2, 0.5, 1, 2, 5, 10, 20, 50, 100, 200, and 500. There is also evidence that the Harappan civilization had some of the most advanced length measurements of the time. For example, a bronze rod found at an excavation was marked in units of precisely 0.367 inch, 0.93 centimeter. Such a measuring stick was perfect to plan roads, to construct drains for the cities, and even to build homes. An ivory scale found at Lethal, once occupied by the Harappan civilization, is the smallest division ever recorded on any measuring stick yet found from the Bronze Age, with each division approximately 0.06709 inch, 0.1704 centimeter, apart.
Who was one of the most prolific mathematicians who ever lived?
Swiss mathematician Leonhard Euler, 1707–1783. Is considered to be one of the most prolific mathematicians who ever lived. In fact, his accomplishments are beyond the scope of this text. Suffice it to say that his collected works number more than 70 volumes, with contributions in pure and applied mathematics, including the calculus of variations, analysis, number theory, algebra, geometry, trigonometry, analytical mechanics, hydrodynamics, and the lunar theory, calculation of the motion of the moon. Euler was one of the first to develop the methods of the calculus on a wide scale. His most famous book, Elements of Algebra, rapidly became a classic. And he wrote a geometry textbook. Yale University was the first American college to use the text. Although half-blind for much of his life and totally blind for his last 17 years, she had a near-legendary skill at calculation. Among his discoveries are the differential equation named for him, a formula relating the number of faces, edges, and vertices of a polyhedron, although Euler's formula was discovered earlier by René Descartes, and a famous equation connecting 5 fundamental numbers in mathematics. Like many in the Bernoulli family, Euler eventually worked at the Academy of Sciences in St. Petersburg, Russia, a center of learning founded by Peter the Great.
What is the difference in sum of cubes?
Similar to squares, there is also the difference and sum of cubes that deals with the factoring of polynomials. The difference of cubes takes the form a 3b3, and can be factored into ab, a 2 plus ab and b2. Thus, if an expression resembles a 3b3, then ab is a factor. Use long division to find the remaining factor, s. The sum of cubes takes the form a 3 plus b3, and can be factored into a and b, a 2 ab and b2. Thus, if an expression resembles a 3 plus b3, then a and b is a factor. Again, use long division to find the remaining factor, s.
What is orbital mechanics?
Orbital mechanics, also called flight mechanics, is the study of the motions of artificial satellites and space vehicles moving under the influence of forces such as gravity, atmospheric drag, thrust, and so on. It is a modern spin-off of celestial mechanics, or the study of the motions of planetary and celestial bodies. One of the main scientists who built the foundations of orbital mechanics was mathematician Isaac Newton. 1642 to 1727, who put forth his laws of motion and formulated the law of universal gravitation. For more about Newton, see History of Mathematics and Mathematical Analysis. For more about Newton's laws, see Mathematics in the Physical Sciences. Today's aerospace engineers apply orbital mechanics to such problems as rocket and spacecraft trajectories, re-entry and landing of space vehicles, rendezvous computations, such as the Space Shuttle to the International Space Station, and lunar and interplanetary trajectories for manned and unmanned vehicles.
What are perpendicular, orthogonal, normal, and tangent lines?
Lines are also classified by their relationship to other angles and lines. Perpendicular lines are two lines, segments, or rays that intersect to form a right, 90-degree, angle. Orthogonal lines are another way of saying lines are perpendicular, but it is mostly used in terms of functions, transformations, and vectors in other mathematical fields. Normal lines are perpendicular lines where each line is perpendicular to a curve, including a line, or a surface, including a plane. And finally, a line is considered to be tangent to a circle if it intersects the circle at exactly one point, also called the point of tangency. Such lines are also called tangential lines.
How are positions on Earth determined?
Positions on Earth are determined using two numbers that represent latitude and longitude. These numbers are actually two angles, measured in degrees. Degree, minutes of arc, and seconds of arc. On a globe of the Earth, latitude lines circle parallel to the equator and differ in length depending on their location. The longest line is at the equator, latitude 0 degrees, the shortest lines actually pinpoints are at the poles. 90 degrees north at the North Pole, 90 degrees or minus 90 degrees south at the South Pole. In the northern hemisphere, latitude degrees increase as you move north away from the equator. In the southern hemisphere, latitude degrees increase as you move south away from the equator. Longitude lines, or meridians, once called meridian lines and eventually shortened to meridians, are those that extend from pole to pole, slicing the Earth like segments of an orange, with each meridian crossing the equator. In the Western Hemisphere, longitude increases as you move west from Greenwich, England, 0 to 180 degrees. In the Eastern Hemisphere, longitude also increases as you move east from Greenwich, England, again, 0 to 180 degrees. All points on the same line of longitude experience true noon, and any other hour, at the same time. But note, longitude lines are not to be confused with time zones, most of which follow a more erratic demarcation. For more information on time zones, see below. For more information about latitude and longitude with regard to polar coordinates, see geometry and trigonometry.
To date, what computer has the top speed in operations per second?
In the 2004 Top 500 list, a ranking of supercomputers by speed. With the results announced early each summer, the top 3 supercomputers were as follows. Note: a teraflop is a measure of a computer's performance, in which 1 teraflop is 1012 operations per second. IBM's Blue Gene /L 70.72 teraflops, NASA's Columbia 51.87 teraflops, NEC's Earth Simulator 35.86 teraflops. One of the next contenders is Sandia Labs' Red Storm, with 41.5 teraflops. This list will continue to change each year as more advanced technology becomes available. In actuality, the fastest computer in the world is the human brain. An amazing computing device with the best processor on Earth. To compare, the fastest computers measure speed in trillions of operations per second. But scientists speculate the brain can handle 10 quadrillion operations per second. The actual numbers are probably even higher than that.
What do we know about Babylonian mathematical tables?
Archaeologists know that the Babylonians invented tables to represent various mathematical calculations. Evidence comes from 2 tables found in 1854 at Sankara on the Euphrates River, dating from 2000 BCE. One listed the squares of numbers up to 59, and the other the cubes of numbers up to 32. The Babylonians also used a method of division based on tables and the equation a/b = ax, 1/b. With this equation, all that was necessary was a table of reciprocals, thus the discovery of tables with reciprocals of numbers up to several billion. They also constructed tables for the equation n3 plus n2 in order to solve certain cubic equations. For example, in the equation x3 plus bx2 equals c, note, this is in our modern algebraic notation. The Babylonians had their own symbols for such an equation. They would multiply the equation by a 2, then divide it by b3 to get x/b, 3 plus x/b, 2 equals ca2/b3. If y equals x/b, then y3 plus y2 equals ca2/b3, which could now be solved by looking up the n3 plus n2 table for the value of n that satisfies n3 plus n2 equals ca2/b3. When a solution was found for y, then x was found by x equals by/a. And the Babylonians did all this without the knowledge of algebra or the notations we are familiar with today.
What was the Turing machine?
In 1937, while working at Cambridge University, English mathematician Alan Matheson Turing, 1912 to 1954, proposed the idea of a universal machine that could perform mathematical operations and solve equations. This machine would use a combination of symbolic logic, numerical analysis, electrical engineering, and a mechanical version of human thought processes. His idea became known as the Turing machine. A simple computer that performed one small, deterministic step at a time. It is often thought of as the precursor to the modern electronic digital computer. And its principles have been used for application in the study of artificial intelligence, the structure of languages, and pattern recognition. For more on Alan Turing, see History of Mathematics.
What is the origin of Roman numerals?
Because the history of Roman numerals is not well documented, their origin is highly debated. It is thought that the numerals were developed around 500 BCE, partially from primitive Greek alphabet symbols that were not incorporated into Latin. The actual reasons for the 7 standard symbols are also argued. Some researchers believe the symbol for 1, I, was derived from one digit on the hand, the symbol for 5, V, may have developed because the outstretched hand held vertically forms a V from the space between the thumb and first finger. The symbol for 10, X, may have been 2 V's joined at the points. Or it may have had to do with the way people or merchants used their hands to count in a way that resembled an X. All the reasons offered so far have merely been educated guesses. However the symbols were developed, they were used with efficiency and with remarkable aptitude by the Romans. Unlike the ancient Greeks, the Romans weren't truly interested in pure math, such as abstract geometry. Instead, they concentrated on applied math, using mathematics and their Roman numerals for more practical purposes, such as building roads, temples, bridges, and aqueducts, for keeping merchant accounts, and for managing supplies for their armies. Centuries after the Roman Empire fell, various cultures continued to use Roman numerals. Even today, the symbols are still in existence, they are used on certain timepieces, in formal documents, and for listing dates in the form of years. For example, just watch the end credits of your favorite movie or television program, and you will often see the movie's copyright date represented with Roman numerals.
What is perspective?
In painting and photography, perspective gives an image depth, allowing a person to perceive 3 dimensions in a 2-dimensional picture. In art, this can be achieved using certain tools of the trade. For example, the horizon line is the eye level of the artist and viewer. By raising and lowering the viewpoint, it enables the viewer to see more or less of the horizontal plane that lies between the viewer and the horizon. The vanishing point is a point on the horizon line at which parallel lines seem to meet. The classic example is how train tracks seem to come together in the distance. The horizontal baseline is parallel to the horizon line and represents the base of the picture plane. The vanishing point is on the horizon line and is directly opposite, or in front, of the viewer. All of these points, lines, and angles and other ways of bringing depth into a painting are based on concepts in mathematics.
How is mathematics used to describe population growth of organisms in a certain environment?
In general, a certain population of organisms from rabbits to humans will grow exponentially if it is left unchecked. That means that in a perfect world a population's rate of increase is constant. This can be seen in the following equations: after 1 year equals P0, 1 plus R. After 2 years equals P, 1 plus R, 2. After 3 years equals P, 1 plus R, 3. After n years equals P, 1 plus R, n, in which P0 is the population today and R is the rate of increase. These equations are further modified for population growth statistics. But such intricate calculations are not within the scope of this book. For more about population growth and biology, see above.
How is math used to calculate the pressure behind a dam?
There are many engineering considerations and calculations needed when building a dam. The most important being the water pressure behind the structure. Engineers know that as the elevation of water behind a dam increases, The height and density of the water causes higher pressures at the bottom of the dam. Thinking in mathematical terms, the horizontal force acting on the dam is the integral of the water pressure over the area of the dam that is in contact with the water. The force exerted by the water pushes horizontally on the dam face, and this is resisted by the force of static friction between the dam and the bedrock foundation on which it rests. The water also tries to rotate the dam about a line running along the base of the dam. The torque resulting from the weight of the dam acts in the opposite sense. For example, take the water pressure on a dam, such as the Hoover Dam on the Colorado River between Arizona and Nevada. Before building that dam, engineers needed to know the pressure not only along the entire structure, but also and especially at its base. In general, the pressure exerted by water equals the density times the depth, in which the density of water is 62.4 pounds per cubic foot. For Hoover Dam, this gives a pressure of 37,440 pounds per square foot, or 18.72 tons per square foot. The pressure calculated at half the height of the dam is 9.36 tons per square foot. This is why the base width of the dam is 1,660 feet, 201.2 meters. It is thicker to compensate for the increase in pressure at the bottom of the dam, while the width of the crest of the dam is only 45 feet, 13.7 meters.
What is a geometric series?
If we add the numbers in a geometric sequence, we end up with a geometric series. A geometric series is obtained when each term is determined from the preceding one by multiplying by a common ratio. There is a constant ratio between terms. For example, 1 plus 1/2 plus 1/4 plus 1/8 plus, and so on, is a geometric series because each term is determined by multiplying the preceding term. By January 2nd. To find the sum of a geometric series, the formula is, sum equals a, rn1, slash, r1, or a, 1 rn, slash 1 r, in which a is the first term, r is the common ratio, and n is the number of terms. For example, to find the sum of the first 6 terms of a series represented by 2 plus 6 plus 18 plus 54 plus 162 plus 486, define a equals 2, r equals 3, and n equals 6. Substitute the numbers, sum equals 2, 36 1, slash 3 1 equals 729 1 equals 728. We could also have determined this number based on the first few numbers, such as 2 plus 6 plus 18 plus 54, as long as we knew the common ratio, the first number, and how many numbers in the series we wanted to add. This is something that can easily be determined based on just these 4 numbers.
What is game theory?
As the words imply, game theory has to do with the mathematics and logic used in the Analysis of games or the situations that involve groups with conflicting interests. Another way to look at a game is as a conflict that involves gains and losses between two or more opponents who all follow a set of formal rules. In particular, game theorists study the predicted and actual behavior of individuals in specific games, as well as the optimal strategies used in the games. Thus, the principles of game theory can be applied to games such as cards, checkers, and chess. Or, they can be applied to real-world problems in economics, politics, psychology, and even warfare. For example, game theory is used to determine optimal policy choices of presidential candidates, or even to analyze Major League Baseball salary negotiations.
How is a curve defined in geometry?
A curve is a continuous collection of points drawn from one-dimensional space to n-dimensional space. It is also considered an object that can be created by moving a point. But note, our usual use of the word curve does not mean a straight line. But in mathematics, a line or triangle is often referred to as a curve. Different forms of geometry define curves in various ways. Analytic geometry uses plane curves such as circles, ellipses, hyperbolas, and parabolas, which are usually considered as the graph of an equation or function. The properties of these curves are largely dependent on the degree of the equation in the case of algebraic curves. Curves with algebraic equations, or on the particular function. As in the case of transcendental curves, curves whose equations are not algebraic. Even more complex are space curves, all of which require special techniques used only in differential geometry. Will be the same as from B to A, and the distance between the points does not change if they are totally shifted over in one direction. Such a sliding over of the points is called translation. For more on this, see elsewhere in this chapter. In addition, the Pythagorean theorem is valid for 3 points that are the vertices. The intersection points of the sides of an angle, of a right triangle.
What is the pH scale?
The pH scale stands for P, potential of, H, hydrogen, scale, or the logarithm of the reciprocal of hydrogen ion concentration in gram atoms per liter. In simpler terms, the pH is merely the measure of the hydrogen ion concentration of a solution. The pH numbers are based on a scale from 0 to 14, in which numbers less than 7 represent acidic solutions and numbers greater than 7 represent alkaline, base, solutions. A reading of 7 is considered neutral. Mathematically speaking, once the concentration of hydrogen ions is determined chemically based on moles per liter, the pH value is established by taking the exponent used in expressing this concentration and reversing its sign. It is most often expressed as the notation pH equals log 10H plus. For example, if the hydrogen ion concentration of a solution is determined to be 10 to 4, or 0.0001 moles per liter, the pH is 4. Many people are familiar with the pH scale from high school. Especially the practice of using special whitish paper called litmus paper to check for pH. The paper contains a powder extracted from certain plants, allowing the user to determine acidity. The paper turns red. Neutrality, the paper stays white, or alkalinity, the paper turns blue, of various solutions. The stronger the acid or base, the more intense the red or blue, respectively. And pH isn't just for use in chemistry class. For example, it is also important to people who work the soil. All plants need a certain soil pH to grow and flourish. Which is why most gardeners and farmers determine the acidity or alkalinity of their soil in order to grow better crops.
What is the Mozart effect?
The Mozart effect is a term coined in the 1950s by physician and researcher Alfred A. Tomatis, 1920 to 2001. It refers to the supposed increase in brain development that children under age 3 experience when they listen to music composed by Wolfgang Amadeus Mozart, 1756 to 1791. A more recent interpretation originated in 1993 from physicist Gordon Shaw and Francis Rauscher, a former concert cellist and expert on cognitive development. After a few dozen students listened to the first 10 minutes of Mozart's Sonata for two pianos in D major, K. 448, the researchers determined that the students experienced a short-term enhancement of their spatial temporal reasoning, based on a certain IQ test. But many other researchers claim that no one has ever been able to reproduce these results. Over the years, the Mozart effect has reached further into the public psyche, with highly debated claims of better health, memory improvement, and therapeutic uses of music, especially classical music. Proponents also claim the Mozart effect can be applied to learning such subjects as mathematics. They believe that exposure to certain types of music, especially classical music early in life, leads to higher future scores in spatial visualization, abstract reasoning, and sundry other mathematical concepts. But all these claims remain highly contested.
How are some economic indicators calculated?
There are many economic indicators that are mathematically calculated, mainly in order to understand a nation's economic health. The gross domestic product, GDP, is the current measure of a nation's economic performance. It is the total market value of all final goods and services produced in a country during any quarter or year. Its calculation includes such variables as total consumer spending, business investments, government spending and investments, and the value of exports minus the value of imports. The Consumer Price Index, CPI, is a measure of the average change over a period of time of prices paid by consumers for a market basket of consumer goods and services. A market basket is based on information from a sampling of consumers on their spending habits, what they put in their basket. There are also the M1 and M2 indicators. The M1 is a measure of the money supply including currency in circulation, such as travelers' checks, deposits, and checking account balances that can be spent immediately. M2 is the M1 plus assets that are invested for the short term, such as certain overnight repurchase agreements, savings deposits, time deposits, less than $100,000, and money market mutual funds. There is also an M3 that relates to the big bucks from places such as lending institutions.
How does a sundial work?
The sundial tracks the apparent movement of the sun across the sky. It does this by casting a shadow on the surface of a usually circular dial marked by hour and minute lines. The gnomon, or the shadow casting angular object on the dial, becomes the axis about which the sun appears to rotate. To work correctly, it must point to the north celestial pole, near the star Polaris, also called the North Star. Thus, the gnomon's angle is determined by the latitude of the user. For example, New York City is located at about 40.5 degrees north latitude. So a gnomon on a sundial in that city would be at a 40.5 degree angle on a sundial. The sharper the shadow line, the greater the accuracy. In addition, larger sundials are more accurate, because the hour line can be divided into smaller units of time. But the sundial can't be too large. Eventually, diffraction of the sunlight around the gnomon causes the shadow to soften, making the time more difficult to read.
What is the historical significance of the barleycorn in measurement?
The barleycorn, just a grain of barley, definitely had a significant historical role in determining the length of an inch and the English foot. For more about the inch and foot, see below. In addition, in traditional English law, the various pound weights all referred to multiples of the grain. A single barleycorn's weight equaled a grain, and multiples of a grain were important in weight measurement. Thus, some researchers believe the lowly barleycorn was actually at the origin of both weight and distance units in the English system.
How does a person calculate sales tax on purchases?
Most states and cities charge sales tax on retail purchases made by customers, from clothes to certain foods. This sales tax is based on a percent of the purchase price, with the percentage of tax called the tax rate. In turn, each state's tax rates vary greatly, often with the counties charging additional taxes. For example, in Vermont, the state and local sales tax rate stands at 5%. Florida has a state sales tax rate of 6%. And in various counties of New York, the sales tax rates start as low as 7.25% to as high as 8.75%.
What is Gödel's incompleteness theorem?
Austrian-American mathematician and logician Kurt Gödel, 1906 to 1978, is best known for his studies in mathematical logic, in particular, his incompleteness theorem. Presented in 1931. This theorem shows that an infinite number of propositions that can't be derived from axioms of a system may be proved by metamathematical means external to mathematics. In other words, mathematics abounds with questions that have a yes or no nature. The incompleteness theory suggests that such questions will always exist. For more about Gödel, see History of Mathematics.
When were the first calendars invented?
Although the first crude types of calendars may have appeared some 30,000 years ago, they were based on the movements of the moon and indicated as marks on bones. The Egyptians are given credit for having the first true calendars. Scientists believe that around 4500 BCE the Egyptians needed such a tool to keep track of the Nile River's flooding. From about 4236 BCE, the beginning of the year was chosen as the Heliacal Rising, when a star is finally seen after being blocked by the sun's light, of the star Sirius, the brightest star in the sky located in the constellation of Canis Major. This occurred, and still occurs, in July, with the Nile flooding shortly after that, which made it a perfect starting point for the Egyptian calendar. The Egyptians divided the calendar into 365 days, but it was not the only calendar they used. There was also one used for planting and growing crops that was dependent on the lunar month.
How have computers been used to factor large composite numbers?
Computers have often been used to factor large numbers, and not just by number theorists having some fun. In fact, factoring such numbers has helped to test the world's most powerful computer systems, to promote designs of new algorithms, and in cryptography used by people who need to protect sensitive information on their computers. For example, in 1978 several computer experts proposed using the reconstruction of the prime numbers from the product of two large prime numbers as an encryption technique. This method of encrypting sensitive data soon blossomed. especially because of the needs of the military and banking industry. The public also reaped the benefit of this idea as it eventually led to encryption. Methods such as the public key encryption for banking and personal pages on the Internet.
How do clinical trials use mathematics?
Clinical trials are used to determine whether a new drug or treatment is safe and effective for the general public. In particular, there are several phases to reach a positive or negative conclusion about the drug or treatment. Phase I takes between 20 and 80 patients and determines the safety, dosage range, or side effects. Phase II tests the drug or treatment on a larger group, usually around 100 to 300 people. Phase III tests an even larger group of between 1,000 to 3,000 people. And Phase IV takes place after the drug or treatment has been marketed and is in use. Overall, each phase has a mathematical theme, each using statistics to determine the possible positive and negative effects of the drug or treatment.
What is a geometric sequence?
A geometric sequence or geometric progression is a finite or infinite sequence of real numbers with the ratio between two consecutive terms being constant, called the common ratio or R. In this case, each term is the previous term multiplied by a given number. In a geometric sequence, the formula for the nth term, in terms of the first number and the common ratio, becomes n equals a 1 r n1. Here the first term a 1, r is the common ratio, and the number of terms is n. For example, for the numbers 2, 6, 18, 54, 100, and 62, a 1 is 2, r is 3, and n is 5. The equation then becomes 2x 35 to 1 equals 162.
Where did the symbol for infinity originate?
Infinity is represented by the symbol OO. A sign introduced by John Wallis in 1655 in his treatise De Sectionibus Conicus. Historians believe that Wallis, a classical scholar, adopted the sign from the late Roman symbol for 1,000. Whether it was from there or another source, the result was and remains the same, a figure 8 on its side, as many people describe the infinity symbol.
What is Pascal's triangle?
Pascal's triangle, as the name implies, is a collection of numbers in the shape of a triangle. Each number in the triangle is the sum of the two directly above. For example, in the accompanying illustration, the 6 on line 5 is the sum of the pair of 3's above. The next line is 1, 10, 1 plus 9, 45, 9 plus 36, 120, 36 plus 84, and so on. Although the triangle was known to both the Chinese and the Arab cultures for several hundred years before, it was named after the person who brought it to the forefront of mathematics. French mathematician Blaise Pascal, 1623 to 1662. For more information about Pascal, see History of Mathematics.
What is the mathematical distinction between weight and mass?
There is a definite difference between weight and mass, which is easily represented in the formula W equals mg, in which W is weight, or the gravitational pull on an object. M is mass, or the quantity of matter in an object, and g is the gravitational pull. For example, if you wanted to lose weight, you could move further from the Earth or live on the Moon. In both cases, the gravitational pull would be less. But remember, no matter where you travel in the universe, you will always have the same mass unless you diet.
In what way do some historians link mathematics to the pyramids?
The pyramids in Egypt were built as royal tombs for the pharaohs, first along the edges of cliffs as low rectangular structures called mastabas, then as tall, four-sided pyramids. The three structures most of us associate with pyramids were built at Giza, near Cairo, about 2500 BCE. The largest of these, the Great Pyramid of the Pharaoh Cheops, measures 481 feet, 147 meters, high. But there are no intricate pathways in this pyramid. It is merely a pile of limestone blocks weighing between 3 and 15 tons.
What is subjective probability?
As the word implies, a subjective probability is thought of as a personal degree of belief that a particular event will occur. An individual's personal judgment is not based on any precise computation, but is most often a reasonable assessment of what will happen by a knowledgeable person. This is usually expressed on a scale of 1 to 0, or on the percentage scale. For example, if a person's baseball team has a winning streak, they might believe that their team has a probability of 0.9 of winning the division championship for the year. More likely, they will say their team has a 90% chance of winning. Not because of any mathematical formula, but only because the team has had a winning record during the year.
What is the millionaire calculator?
The millionaire calculator, invented in 1892 by Otto Steiger. saved many of the problems associated with other devices' multiplication. While earlier machines required several turns of their calculating handle to multiply, the millionaire multiplied a number by a single digit with only one turn of its handle. Its mechanism included a series of brass rods varying in length. These rods executed functions based on the same concept as Napier's bones. For more about Napier's bones, see above. The calculator was a hit, and around 4,700 machines were manufactured between 1899 and 1935. The slide rule was not immediately embraced by scientists, mathematicians, or the public. It took until about 1850, when French artillery officer Victor Meyer Amédée Mannheim 1831 to 1906, standardized the modern version of the slide rule, adding the movable double-sided cursor that gives the slide rule its familiar appearance. Slide rules were used for many decades as the major calculator for the sciences and mathematics, and ranged in shapes from straight rules to rounded.
Who was Scipione del Ferro?
There were several mathematicians in the 16th century who worked on algebraic solutions to cubic and quartic equations. For more information on cubic and quartic equations, see algebra. One of the first was Scipione del Ferro, 1465 to 1526. Who in 1515 discovered a formula to solve cubic equations. He kept his work a complete secret until just before his death, when he revealed the method to his student Antonio Maria Fiori.
What are the various forms of calculus?
As mentioned above, calculus uses infinite processes that involve passage to a limit in order to solve its functions. It includes a formal set of mathematical rules applied to changing quantities. Many mathematicians break down calculus into two branches. The first is integral calculus, or the general problems of measuring length, area, volume, and other quantities as limits by approximating polygonal shapes. It finds the quantity when the rate of change is known. The second branch deals with discovering the tangent line to a curve at a specific point, or differential calculus. In this case, the calculus determines the quantity's rate of change. There also are several other forms of mathematical analysis that depend on calculus methods, such as vector analysis, tensor analysis, differential geometry, and complex variable analysis.
How is modeling and simulation used in geology?
Like so many other fields of science, mathematical modeling and simulation is used in geology to understand the intricacies of physical events in the past, present, and future. For example, hydrologists, geologists who study water flow above and below the Earth's surface, often use models to simulate the effects of increased groundwater pumping of wells. They may also use a simulation to determine how much water can be presently pumped out of a well, or how much can be pumped out in the future without harm to the environment. Other hydrologists may use modeling to understand the flow of water in a river, bay, or estuary, for example, to determine how the water erodes a shoreline. Still other researchers may model how snow on a volcanic mountain melts, gathers debris, and potentially flows toward populated areas during an eruption event. For more about modeling and simulation, see Math in Computing.
What was the progression of logarithm development?
The invention of logarithms was a long process, starting with Scottish mathematician John Napier. 1550 to 1617, also known as Laird of Merchiston, who first came up with the idea of logarithms in 1594. But the actual invention and announcement of logarithms would take another 20 years. In 1614, Napier would publish Mirifici Logarithmorum Canonis Descripto. Description of the wonderful canon of logarithms, which offered tables and rules for their use. Not long afterward, in 1617, English mathematician Henry Briggs, 1561 to 1630, published Logarithmorum Cilius Prima, logarithms of numbers from 1 to 1000. Introducing the concept of common logarithms or logarithms based on the powers of 10. And finally, independently from Briggs and Napier, came Swiss mathematician Just Bürgi, 1552 to 1632. Who in 1620 presented Arithmetisque und Geometrische Progresstabulum, a German work presenting the discovery of logarithms. These discoveries differed in several ways. Napier's approach was algebraic, Bürgi's was geometric. There were differences from the common and natural logarithms we use today. And neither Napier nor Bürgi mentioned the concept of a logarithmic base, something that Briggs presented. By 1624 Briggs would write Arithmetica Logarithmica, the arithmetic of logarithms, extending his common log tables from 1 to 20,000 and from 90,000 to 100,000. But the work on logarithms did not end with Napier. Briggs, or Bürgi. Natural logarithms eventually evolved out of Napier's original work. Defining logarithms as exponents was finally recognized by English mathematician John Wallis. 1616 to 1703, who presented them in his 1685 publication, De Algebra Tractatus, Treatise of Algebra.
What is an asymptotic curve?
On a graph, a line that approaches close to a curve, or even an axis, but never quite reaches it, is an asymptotic curve. In an example similar to one of Zeno's paradoxes, see Foundations of Mathematics. If a kitten standing a yard from a box walks half the distance to the box each hour, it will technically never reach the box. Because the distance it travels each hour is never more than half the remaining distance to the box. If this problem was illustrated as an equation, the answer would never quite reach its solution. A more mathematical example is the exponential function y equals 2x, which results in a line that approaches but will never quite reach the x-axis.
Who was Oliver Heaviside?
English electrical engineer Oliver Heaviside, 1850 to 1925. Was a self-taught genius who made several contributions to the field of electricity and even atmospheric studies. In 1902 Heaviside predicted that there was a conducting layer in the atmosphere that allowed radio waves to follow the Earth's curvature, a layer now named after him. In electrical engineering, Heaviside was best known for operational calculus, a tool for solving linear differential equations with constant coefficients. It was usually applied to brief or fleeting, called transient phenomena, and was very similar to Laplace transform in its calculations. Although Laplace had developed his ideas almost a century before, Heaviside knew nothing of them, because they were not well known during his time. But Heaviside's operational calculus did have its problems, as well as its critics. It was severely limited because of its lack of mathematical theory. This not only limited its applications, but also created many uncertainties and ambiguities in the equations and solutions. Today, operational calculus has been replaced by Laplace transform, especially in fields such as electrical engineering.
What is number guessing?
Number guessing is a game, some say trick. Some people can do number guessing in their heads, as long as the numbers are kept small. Have a person think of any positive integer n, not 0 or any negative numbers, and apply the following steps. For example, a person chooses the number 25 and keeps that number to humor herself. Ask the person to compute 3xn, 3x25 equals 75, ask if the number is odd or even. Odd. If the number is even, tell him or her to divide the number by 2, if the number is odd, tell him or her to add 1 to the number, then divide that number by 2. 75 plus 1 equals 76 halves equals 38, tell him or her to take that number and multiply by 3, then divide by 9. 38x3 equals 114/9 equals 12.666. Take that number and multiply by 2, 12.666, x2 equals approximately 25. The answer should be the original number or close to it.
What are events in probability?
Probability is a branch of mathematics that assigns a number measuring the chance that some event or any collection of outcomes of an experiment will occur. It is a quantitative description of the likely occurrence of the event, conventionally expressed on a scale from 0 to 1. For example, a very common occurrence has a probability of close to 1, an event that is more rare will have a probability close to 0. In more common usage, the word probability means the chance that a particular event, or set of events, will occur all on a linear scale expressed as a percentage between 0 and 100%. An even more detailed way of looking at probability includes the possible outcomes of a given event along with the outcome's relative likelihoods and distributions.
What is the set theory approach to arithmetic?
The set theory approach to arithmetic is defined in terms of the non-negative whole numbers 0, 1, 2, 3. These numbers are identified with specific sets based on the placement and number of brackets. For example, mathematicians identify 0 with the empty set, 1 is identified with, 2 is identified with, 3 is identified with, and so on. Each bracket is an interpretation of the empty set and 1, or
Do numbers continue into infinity?
When most of us think of infinity, we envision the universe continuing on forever. And in mathematics, we often think of numbers that are never-ending. Sometimes it is difficult to understand infinity. Since our own lives and most of our experiences are finite, they eventually end. Infinity is a mind-boggling concept. There are several rules to mathematical infinity. The three most important are, no matter how high you count numbers, you can always count higher. No matter what length you draw parallel lines, they will never meet, and when starting with a line, dividing it in half, then dividing that in half, and so on, you will never stop dividing the resulting line segment. Even though scientists and mathematicians agree that infinity exists theoretically, it is often a difficult concept to understand and accept.
How can I prove that 1 equals 0?
There is a way to show that 1 equals 0. And it includes an interesting proof. Consider two non-zero numbers x and y such that x equals y. If that is so, then x2 equals xy. Subtracting y2 from both sides gives x2 y2 equals xy y2. Then dividing by xy gives x plus y equals y, and since x equals y, then 2y equals y. Thus 2 equals 1, the proof started with y as a non-zero, so subtracting 1 from both sides gives 1 equals 0.
What is a placeholder?
A placeholder is a number that, as the name implies, holds a place. Initially, various cultures used a placeholder, often a dot or a space, to show an empty spot or place not used in a numeral, or other way of counting. This was in place of what we now call a 0, 0. A symbol that is not only a placeholder but also an essential number in our numeration system. For more about the evolution of the symbol 00, see History of Mathematics.